Hey everybody, welcome to our intro to Git and GitHub presentation. Before I go on ahead and get to the main event, I have a couple of announcements, or ACM related announcements to talk about really fast here. So let me just get those out of the way. So here are a couple of our social media links. You know, please follow us if you so choose to. I think we would appreciate that. If you like that Discord server at the top link there, usually we'll post all of our updates, like you know, workshops and events. And it's a good way to stay in tune or stay tuned for most ACM related events. So yeah. And about membership, just a recap for those who aren't familiar. This year, ACM's membership is free, but the only condition is that you have to join roughly 20% of the meetings throughout the year, or excuse me, semester. So there's a couple of benefits to being a member. You know, you do get a shirt. You also get to participate in a couple of giveaways. And also we have a banquet in the spring, which you know, we'll announce more details about that when that comes. But yeah, that's what we have for being a member. Yeah, for the fall. Well, so yeah, for each semester, you just have to attend 20% of the meetings. So I believe we have about 75 per semester, so around 14, 15. So here are a couple of our upcoming events. So we have our hackathon that's focused on marginalized genders, Code Quantum. That'll be coming up pretty soon here in a couple of weeks. You know, I'll probably just give you guys a minute here to scan the QR code for those of you who are interested. Everyone good? Okay, I'll move on. So this Thursday, ACM-W has their game night. So it's an in-person only event, and it's in the Bear Room in the Student Union. So it's pretty close around here. Shouldn't be too bad if you're able to find your way here. Yeah, basically it's a game night, and that'll be happening 3 to 4 this Thursday. So this Saturday, or I guess every Saturday, we have meetings for Icpc, and basically that's just competitive programming. So they happen for about they happen every 10 a.m. to 1 p.m. every Saturday. So you can attend either virtually or in person. So they're hybrid meetings. But yeah, you know, coffee's provided, and so are donuts. So for those of you who just like food, probably fine for you guys too. And here's the QR code to sign into today's meeting. You know, like I said, there's a couple benefits of signing in and being a member. So, you know, I'll probably just give you guys a chance to scan that. And if you guys can't scan the QR code, there's a link right, that link below it should lead you to sign in case you prefer that. And we'll post it back at the end. So if you missed it, you know, don't fret too much. Is everyone okay? Okay, I'll move on. So let's get started with our main event. So this is just going to be, you know, a relatively quick introduction to Git and GitHub and what exactly they are. And I'll probably just go over a couple of ideas and terminology when it comes to topics relating to Git and GitHub. So firstly, the thing that I want to make clear, and I think this is necessary to have, is a little bit of context. So basically, what Git is it's a version control system, and you're probably asking, well, what is a version control system? So think of it as a way to keep a track of files or a file or files that are changed in a code base. And really, and so, like I said, Git is an example of this. But the most there's a couple of stellar features to this. Like for example, if you're a web developer and you have several iterations of your website, and maybe you just don't like that one change that you have that's up to date, and you want to revert back to a previous design, you can choose to do that by going back to a snapshot that you've taken of when your code base was exactly like that old version. And maybe you can make some changes to modernize things, or you can go back and forth through versions as you see fit, and that's kind of the power of version control. And also collaboration is another one. Especially when you can just have a code base stored somewhere, maybe up on a server, and all your friends or people or colleagues who you're working with, all they have to do is just they can just work on that code remotely by copying it to their local machine and modifying it, and then they can upload changes. But we'll discuss a bit more about actually how that works a little bit later here. And the last point I want to make is that these are pretty much industry standard tools. Although companies might not necessarily use Git and GitHub, they might use some derivative or something extremely similar, or they might self-host their version of Git. I think these tools are very, very useful for any developer. And I can't tell you how many times it's been very nice to just go in and change my code through a couple of commands. But yeah, let's get into what Git and GitHub actually are. So I want to make one thing clear, that they are not the same thing. Although they might sound like the same thing, the main difference here is that GitHub is an internet or cloud-based solution to Git. It allows the hosting of remote repositories, which don't worry about what repositories means right now. I'll kind of get into what that actually means a little bit later. But Git is a version control system, so as we discussed, it keeps track of changes and how you've affected the repository that you have. And again, you'll catch me saying repository. I'm going to explain that in a little bit. Git, so kind of like how I explained earlier, the way Git works and how it tracks your changes is it usually tracks snapshots of your code. And what I mean by snapshots, it catches exact moments and the exact way or moment your files are and how they've been changed. And so, like I said earlier, you might want to go back and forth between these versions, and that's why having such tools is powerful. So again, like I said, you'll notice I use the word repository or repositories often. So what does that actually mean? So the word, so in the context of Git or version control systems, what repository actually means is it's like a code base. So it is the place where files are being stored in a project, and you can choose to access them as you wish and modify them. And again, you can make these snapshots or these a frame of these files and these changes. And so, again, like I said, GitHub is a cloud or internet-based solution to Git, where you can, where they host all these repositories remotely and through the internet. So, and typically in Git itself, you're mostly concerned with a local repository. But we'll kind of talk about how the local and remote repositories, which in this case GitHub, are being affected and changed in a little bit here. Oh, excuse me. So just to get you guys started, so first, just go on ahead and create an account on GitHub if you choose to follow. I'll try to make, I'll try to demo through at the end, just so, everyone kind of gets an idea of how things will go. But so you'll want the Git client for whatever operating system you're using. The Git client is basically kind of like how we described. That is Git itself. Where GitHub comes into play a little later that's what we're going to discuss in I believe a couple slides here. So again, the Git client's kind of important. So I'll kind of so I'll probably so I believe that link is being dropped in the stream chat. Is that all good? Okay. So if you're on the stream, you can feel free to click that link and download the Git client. And it'll be kind of important because we're going to use the Git Bash terminal and actually use a couple commands to play around with Git and GitHub later on. And so the setup here. So again, I'll kind of so maybe right now actually I'll talk a little bit about the authorization of tokens and stuff. So here, let me go on ahead. So kind of what I described here, right? So in the past, what you used to be able to do is actually. So I'm going to go ahead and show you. Can't type today. So typically, when you're so this is kind of the download page for the Git client. So obviously, depending on what operating system you're on, you'll get this client, and it comes with several tools like the Git Bash terminal, which is what we're using. But as far as linking that to your account on GitHub, so in the past, what you used to be able to do is you used to give yourself an alias and then the email in which your GitHub account is associated with. So as of, I believe, August 13th, that has changed. So you can still use your email to log in. However, when you start doing actions like pushing, which again we'll talk about a little later, you're not going to use your password, but you're going to use a personal authorized token, which I can kind of explain here a little bit. So basically, I believe the reason that they deprecated passwords in favor of tokens is because of security concerns. And so the process is typically what we'll do here. So I'll probably tab out to my presentation. So what you typically do is you go into your account settings and you generate a token to use, and then you'll use that token depending on your operating system's credential manager, and you'll log in using the token and your email. And so you'll see in this next slide. So yeah, you'll generate a token, and then it kind of generates this this string that's kind of a mishmash of numbers and letters and symbols, and that's what you're going to use in lieu of your password to authorize your Git account. But first thing, what I do want to talk about really quickly here is you'll start by creating a local repository using Git init on a desired folder. But again, I don't want to go into too much detail here because the main focus, we'll get to Git init when we're talking about how the workflow of Git and I guess, in a sense, GitHub works. So as far as the Git workflow, right? So there's 4 main states. I guess you could argue that it's 3 because the local and the remote repositories are kind of they're somewhat close together, and I guess it really depends whether or not you're concerned with a remote repository. I mean, in our case, we are because we're using GitHub. But essentially, the four main states are working directory, staging area, and then local Git repository and the global Git repository, or I guess in this flow chart here, it's referred to as remote. This slide kind of describes 2 of the stages, but I want to make sure I make this simple. So essentially, the first thing you do, right? So if we go back to our flow chart, so the first thing we do is we're in our working directory. And what this means is that we're in a stage where we're kind of editing our code. We're making changes. Maybe we see some bugs or imperfections, or maybe we need to add a new header file that defines constants or very important functions. So typically in the working directory, right, that is when you start. That is when you're modifying and changing files and you're writing your actual code. And so the next slide here, right? So you'll see the command git add. So essentially what git add does is Git actually knows what files your repository is working with and what files they're concerned with. So essentially by using the command git add file name, so file name is obviously what file name you want to add to your repository, that explicitly tells your Git client to say, okay, I want to keep track of all the changes done to this file within the repository. And you can use the git add and then just a period, and that's basically shorthand syntax for saying, okay, add the most recently changed file. But in this stage, right? So yeah, basically you make all your code, you change whatever you need to, and then you can use git add to kind of add what you desire, and that leads you to the staging area. So essentially the staging area is when you have all these changes and you've added the files and you know which ones you want to consider, right? So when you use git commit, right, that essentially you're essentially saying, okay, I want to like commit these changes, I want to go forward with these changes onto the repository. And for those of you curious, right, the -m basically means it's a message. And so I'll kind of get to a little later on why it's important to have clear messages and how to and just kind of a very bare bones guideline on how to do this. It won't be terribly complex, but just to reiterate, essentially we've started by making changes to our code, adding them to our repository, and then once we're ready to push these or commit these changes, we use git commit. And so now we're going to head to our next stage, right? So after we've added and then committing, right? So now we've made all these changes to our local repository, right? And so I'm going to talk a little bit about Git Push here later on, but what I want to talk over is how does GitHub actually know, like how do you link your local repository to the remote repository you've made over the internet? Well, essentially, first thing you have to do is you have to create a repository on GitHub. So basically on your main menu, you'll just click the little plus button and then you'll click new repository, and you'll change a bunch of settings there. And so I'll go over that a little more towards the end when we're doing our actual demo. But the command here, git remote add origin, that essentially tells, okay, where's the origin repository located at? And then essentially you're just going to use the link of your GitHub repository, which is usually your username followed by the name of the repository with the .git extension. And so so going back to what we're talking about for a flowchart. So when you're actually ready, so you have all these changes done to your local repository, right? So you've changed or added these files, and then you're ready. So this is kind of the last stage here. So Git push, or when you push changes after committing them, essentially what that does is that it'll push and make any changes final to the repository you are aiming at, or to the remote repository that you are aiming at. So this command here, git push and the -u flag origin main. So essentially what that does is that U defines the upstream branch. So, because we only have one repository and it's called main, because we only have one repository, one branch, which, again, I'll get to that terminology a little later on, main, that's the only one we're really concerned with. Usually afterwards, just git push is sufficient because it already knows what branch you're targeting. And again, don't worry too much about branches. We'll talk about what they are in a little bit here. But before I continue any further, does anybody have any questions? Is it all clear? Okay.
What's the git push origin main?
So essentially what that does is, so I'll go back here for a second. Thank you. I was a little too faster. So essentially what that does is that it'll basically, what you're doing is you're saying, okay, I want to establish that the changes that I will push from now on are going into this main branch. So essentially, when you do git push the -u flag, the upstream flag, meaning you're defining that origin. So main of origin, right, is the. Oh, I'm so sorry. I apologize. So the gentleman here, he asked, what exactly does git push -u origin main do? And essentially, what that does is it basically tells the your repository to push these changes onto the main branch of origin. And as you'll see in this previous slide, right? So essentially, origin, right? Origin, that means our destination, right? So we've said that origin here in this case is the remote repository we're aiming at. So essentially, that -u flag and everything else basically defines the target. So the remote repository and the branch we're targeting. And again, like I said, git push is usually sufficient afterwards because your repository, your local repository, in your Git configuration, or at least for that repository, they kind of recognize that that's where you're targeting. That's what you're targeting. So any other questions? Okay, I'll go ahead and continue. So this is okay. So essentially, so when you want to receive changes, right? So let's say, so if we go back to what I was talking about here, right? So, let's say your friend Mary, right? She's made a bunch of changes and she's gone through the same process you have, and she's added, committed, and pushed all of her changes, right? And so what if you want to get her changes? What if you want to see what she's done? So that is what we want. So we'll do a git pull, or we will pull the repository in that case. And essentially, what pull does is that it'll take any changes from that remote repository and then incorporate them back to your local repository. Because remember, the local repository is what you're working at the moment. And so, yeah, like I said, it'll just incorporate those changes back into your local repository. And so, that kind of more or less restarts the workflow. I don't know if that's entirely correct. But yeah, essentially, that's how you start kind of getting these changes back and you continue development. I don't know if that was entirely clear or not. If anyone has questions, feel free to stop me. So yeah, again, kind of like repositories, you heard me toss around the term branches or branch. So what exactly does that mean? So think of branches as like the kind of so think of it as like part of the code that has been derived. So what branches are is they kind of, as the name implies, they sort of branch off. And so you have, so when you're working with different, so when you make a different branch, right? Essentially, you have it's kind of like a copy of all the code. But what branches are so good for is that they allow you to continue development without actually affecting any other branches. So, like for example, let's say that you've been working on a software feature, right? And then you don't want to actually affect the main repository you've been working on. So if you make a branch, you can kind of start working on these changes in a separate sort of duplicate code base. So you don't actually have to, so maybe if you mess up something, it doesn't actually affect the main branch. And then you might not have to spend hours seeking a bug. And so typically in Git, what you'll do is you'll run the command git checkout -b and then new branch name. So that is the name of the branch you're going to be establishing and then using. Yeah, but you only use the -b flag if the branch does not exist beforehand. If it does exist beforehand, you can simply just use git checkout and then the branch name that already exists. So I'll go ahead and continue. So another part of branches, right, is pull requests. So talking about our sort of example that we described earlier, so let's say maybe a team of software developers are working on a brand new feature and they've created a new branch specifically to test and kind of refactor their approach over and over and over. So what maybe they're almost done this extensive testing and they're ready to actually add that feature into the main piece of software, right? So what most Git clients or what most Git services do is they have this thing called a pull request. Essentially, what a pull request does is that it will sort of open up sort of a forum for discussion about these changes. It'll display these changes and then kind of detail them, and then it allows for you to communicate to your to the people you're working with on this repository about what changes are being made, and you can discuss maybe they're good changes, maybe they're bad changes, maybe some designs need to be reconsidered. And so this feature isn't really an inherent thing of Git, but it's typically found in services that host Git, so sort of like GitHub, Bitbucket, and some of those that you've seen around. And Bitbucket is basically just another GitHub alternative, which we won't really be discussing, but it's good to know. And so the final part here, merge. So what merges are is they essentially combine these branches that you've been working on together, and usually you'll have like some derived or modified branch, and then you'll want to combine that back into master. So what git merge modified branch does, that command you see there, so essentially what that does, it takes the modified branch you've been working on, and then that merges it to another branch, which in the most typical case, it's usually main or master or wherever the main code base is actually held. And again, this is useful for testing and developing and adding new features without conflicting, without having any conflicts in the main code base. So now I will actually go over kind of a demo on how to get started. So firstly, before I start, does anybody have any questions? Yes.
I thought GitHub was just like a site where people can like share and exchange code with each other.
That is true. I mean, that is technically true because you are, you can still look at these code bases, these repositories, and you can still kind of, you can still download them. You can still modify a couple of your own. So technically, you are still sharing and looking at code, except, oh, sorry, slip of the tongue. This gentleman here, he asked, isn't GitHub a place where you share code? Or right? Was it share more code? Oh yeah. So while it is true, right? You can still see repositories and code bases, right? Like they are still public. You can still look at them, right? Except GitHub is a lot more complicated than it actually looks. There's a lot so today we kind of just discussed like sort of the bare minimum of how the inner workings, or maybe not inner workings, but how a developer would typically work on using tools like GitHub to get their code out there, and of course share it with other people. I hope that answers your question. So now I guess I'll go ahead and move on to the demo. So the first thing that we'll do, right? So I'm going to go onto GitHub. So I have already created an account. So you'll see the little icon right there. So the first thing that we'll actually do is we'll actually start creating a repository. So we do that by clicking this plus button, and then you click New Repository. So in our case, I'm going to just name this repository ACM Git Workshop, or I'll just say GH Workshop 2021. And so I want this repository to be public, so I will keep it like that. And for now, I'm just going to ignore these settings. They're not really important at the moment. So I'll go on ahead here. Okay, so right now, what we've done is we've created this really, really bare bones repository on GitHub itself. So this is kind of a remote repository where things will actually start to go. So what I will do right now is I will open up this terminal. So this is Git Bash. So this is part of what you've installed. So when you install the Git client, this comes with it. And so typically, the first thing you should do is you should add your credentials in so that GitHub or Git or GitHub, right? Well, I guess GitHub, since you're pushing your changes through, knows who you are. So typically, in my case, right? So Windows, right? So what we'll do is we usually go to the credential manager, and then we'll click on Web Credentials, right? And then I believe we should be able to add our credentials using. And so for the username, you'll use your email, and then for your password, you'll use the personal access token that I kind of briefly talked about earlier on here. And just to kind of review here, in order to generate one of these tokens, you go to your account settings. So you click on your icon, and then you go to settings, right? And then once you go to settings, you'll go to the bottom, and you'll go to developer settings, and then personal access tokens, and then you generate one. And you basically, and in this case, right, since you're using your Git client and you do want to modify a lot of things, you probably want to check most, if not all, of these settings. And once you're done doing that, you'll generate your token. For the purposes of this tutorial, I won't really go over that, because it's a lot more. It takes a lot more time than we have. But I just kind of wanted to briefly talk about it. If anyone has any questions about it afterwards, I feel free to ask me. But I will go back into the Git Bash terminal. So right now, so typically when we open Git Bash, in my case, right, Windows, you'll typically end up at the home directory. So around here, right? And so, so I guess my question here is, have any of you been exposed to the command line, or at least how it works? So you have. Okay. So for the purposes of this tutorial, I'm going to kind of explain some of these commands that we do, and this will be nice because you'll kind of get a sort of a beginner understanding on how to navigate it. So the first thing we want to do is we want to navigate to the folders or directory that we will be saving all of our work in. So we do this by using the change directory command, or CD, and then we specify a location afterwards. So because we want to go to that document/GitHub or home/documents/GitHub, and for those of you who don't know, the tilde stands for home, or your home directory, we will go ahead and go there. So documents and GitHub. And so we have changed our directory to the GitHub, so where we'll store all of our where we will store all of our files. So now if we want to list the items under this directory, we can do ls, and that what that does is it lists all of these different folders and files under that directory. And so the ones with the slash and afterwards or as a suffix, those are folders. And if they don't have that, they're typically files. So for our example, I'm going to make a directory, right? And I'm going to call it ACM Workshop GH 2021. And then what I will do is I will change my directory to that. And so right now we're kind of in this blank slate right here. And so what we have is just this blank folder. So the first thing that we need to do is we need to type git init. And what that does is kind of like how I described, it basically initializes that Git repository. It basically tells it, okay, well, this folder is going to be a Git repository. So the first thing that we will go on ahead and do is we will create what is called a Readme file. And what a Readme file is essentially is, or I guess this is technically a markdown file by extension. Essentially, these are typically, when you go on GitHub, right, these are typically displayed at kind of the at the body of the repository. And essentially, they use markdown formatting. So if you used something like HTML before, they have a very similar syntax to that. So what I'll do here, just kind of just briefly, is I will create a README. So what I will do is I will use the VI text editor, right? And I'll create a README, just simply called readme.markdown. And so what I will do is I'm right now I'm essentially creating a description. So I'm going to use that sharp to give this title a big, a large font size or heading. And so I will say, ACM workshop. And then maybe I'll say, I don't know, the beginnings of Git and GitHub for beginners. And then maybe I want to make another heading that's smaller, and I do that with 2 sharps. And I say content, or just as an example here. And then I can say, this will go over the basics of Git and GitHub with an example. And so for those of you who don't know, I'm using the VI editor We covered Vim in the last intro to tech, but essentially what that is Vim is actually just a Vi. It stands for Vi improved. So the syntax is a lot similar. And so what I'm going to do to save this README is I'm going to type colon, or I typed ask, right? So colon WQ. That should work. Oh, I think I'm blind here. It's my bad. Is that, yeah. Oh, here, sorry guys. Yeah, so that is saved, so we're all good. So the first thing we want to do is we want to make sure we add this file to our repository. So git add readme.md. And so now Git kind of knows it's already there. So now I will do what I said before, and I will kind of access I will access sort of a link. So so I could technically do this remote origin step afterwards, right? But I'm just going to do it right now, just to show it off. So right now I'm adding the repository, or I'm establishing the link that this repository, the remote destination, is the one we just created. So I've added that. And now, like we mentioned before, right? So after adding, we will have to commit. So I will do git commit, right? And so I will use the -m to make a message. And then I will say readme changed the readme file, or I guess added readme. Okay. And so now that that has changed, all right. So now we need to do git branch and then -m main. And so we do want to create a branch, right? And so now that our changes are final. Oh, and actually one thing I do want to mention is that you do see master, and then you'll see how I've changed that branch to main. So typically when you see documentation here, the words master and main are kind of interchangeable. It's just slightly changed terminology. But they mean the same thing, that we're working with the head or the main branch of our code base. Right, so continuing where we left off, right, we do want to push these changes. So we will do git push -u origin and the main. And so now we're pushing all of our changes. And so let's switch back to our repository, right? And take a look. We have so that has essentially been our first commit. And now we see that these changes are reflected in our GitHub repository. So I want to walk you guys through another example. And now what I'll do here is I'm going to model just a tiny dice using object-oriented programming in Python. It won't be terribly complicated, and if there are, please interrupt me and ask questions. So I already have this repository here. I have this one. And so right here, right? So what I'll do is I have this link here. And so what I will do is I'm going to do something called clone. I didn't talk about this in the slides, but essentially what cloning does is it will clone a repository to a directory. So if I go into a different folder here, right? So change directory, and that .. just means the previous folder. And then I'll just say, I don't know. So I can do git clone, right? So cloning, telling that I want to clone this repository. And then I will paste in using shift insert in my case. I will paste the repository link, and I will press enter. And so now it has cloned. And if we list our files in folders here, we'll see that the ACM template repo, which is what we were interested in cloning, is there. So if we change our directory, oops, my bad. And we list our files, we don't really have anything here. I kind of want to just demonstrate what cloning was, but what I wanted to do is, because we're more focused about our actual repository, I'm actually going to copy this, or more importantly, let me guys show you what our example here. So right now we have like this sort of bare bones code, and essentially we're just modeling how a die should work using classes. And so, again, I hope, I won't go over too much detail over object-oriented programming, but I merely wanted to show this as an example. Since it really isn't for the scope of this workshop, but I'm merely using it to demonstrate some Git features. So I just want to show you guys how the file looks like, right? And so since I have Python installed here, I can kind of demo it. And so maybe, and it just asks you to enter the sides of the die. I say 6, and then it tells me, oh, you have 6 sides. So what I'm actually going to do is I'm going to copy this file, and then I'm going to make the destination, right? So ACM and then main.py. So I have copied that file into our main repository that we're interested in working on. So we will go back and then ACM workshop, and then we'll list our files. So as we see, the main.py file is there. And now I actually do want to change this file, right? So right now I have this bare bones dice class, right? And I want to kind of emulate how a dice actually works. So the first thing I will do is I will make a constructor. All right. Are any of you not familiar with object-oriented programming? If you aren't, feel free to interrupt me and ask questions. But essentially, what I'm going to start doing here is I'm going to create a constructor. So for our dice, right? And then I will say that number of sides is the variable we're interested in. And then we'll do self.numSides equals numSides. So yeah, we've essentially just created a constructor, and this dice will, tell us the number of sides. And so maybe we want to get the number of sides. Okay, so what we'll do is we'll just do return and self.numSides. And then just to kind of test our class here, I'm going to go ahead and then I'm going to do D1 or dice D1, and then or I guess D1 6, right? And then I'm going to do print D1 dot get num side. Oh, I guess I kind of screwed that up there. Let me just correct that. So get num sides. And then just do that, and I'll save and quit, and I will run this once again. Oh, my bad. I'm sorry. So yeah, I probably don't want to spend too much time here, but what I actually have this code kind of already here, but I do want to kind of walk you through how this all works. So I've just kind of switched to Visual Studio for the sake of it. So we create a constructor here, and then we want to print the information of the dice. Okay, so nothing too difficult. And then, like we said, we want to get the number of sides, and then we want to roll the dice here. So we've imported the random module, and so that it's a pseudo random number generator. So it doesn't it's not truly random, but it will just pick sort of pick a number between 1 and then the number of sides inclusive, and then it'll just return that. So what I am going to do is I do actually want to go over a little fun program here I wrote. Oops, my bad. Just undo that. So 6, and now so for now we're just going to leave this as is, and maybe we want to print information about the dice, and we'll say self, and then maybe we'll say, okay, print this dice has this number of sides. And for those of you unfamiliar, I'm using a printf syntax in Python. So I will do self.numSides to refer to the number of sides. Okay, and that's probably fine for now. Or my bad. Oops, I guess I probably screwed something up. Anyway, so let's say that maybe we So tell you what, I'm actually going to talk about this main solution I have here. We essentially make a dice class. We have a constructor, and we have a couple of functions. Like we want to roll the dice, choose a random side, and then we make this little function here to print the number to actually print. So how you guys know how a six-sided die has just dots or has dots depending on the number of you've rolled. So what I've done here is I've sort of emulated that, so I've sort of emulated that. And so just to keep things simple, I have basically said that if the number of sides is more than 6, then we're just not going to care about it, and we're going to exit the function. Otherwise, we go on ahead and continue. And then what we do is we use a dictionary to map the number rolled to the dice number. So here, I will just go ahead and kind of show you guys. I want to run this program just to kind of show you guys. So I'll save it as main, and then I'm going to go ahead and quit this. And so I will go ahead and move whatever's in, so main.py, and then I will move that to, and then main.py. And so let's open up our program again. And so, we have this. So again, we have this program here. And so let's, for example, run this program. And so take a look. So essentially what we've done is we've rolled a dice, 3 or 4 different times. And so that on that first one, we've essentially called, so right here, we established our die, and then we print the number of sides, or print dice side. So I made this function that essentially just prints it here, and it maps to a dictionary to a string. And then I'm just doing 3 separate dice rolls. But maybe we don't really want those, and instead we just want to have multiple dice sides, right? And so go ahead and WQ that, and then let's run our program. And so you can kind of tell that we've rolled 3 6s. But if we run it again, hey, look, we have 1 3, 1 5, and then 1 3 again. And then let's run it again. Oh, take a look. We have 1, and then we roll 2 times. So it's not terribly complex. But let's say we've modeled this dice, and that maybe we're so proud of our changes, we're so proud of our 6-sided die, that we want to commit this. So like I said before, we want to add this to our repository, or actually, I don't know if that fully works. But anyway, I've added the main.py file to our repository, and now I'm going to commit this using, like we did before. So main.py, and we'll say created essential dice class, or I guess class, and we'll just leave it at that. So we'll commit our changes, right? And so now what we will do is we will push these changes and say, take a look. As you can see, that it has told us, hey, look, we have written 641 bytes, which should be the size of our Python file, or we'll probably be able to tell. So if we switch back to our repository here, oh, my bad, this is the template one. If we switch back to the repository that we were working on right here, we will see that 34 seconds ago, we just pushed this commit. And if we take a look, it's the exact program that I wrote. So that's basically the introduction to Git and GitHub. I hope that was clear and thorough, and I appreciate you guys for coming. And if anyone has any questions, feel free to ask. Thank you. Nobody in the stream chat has questions? Okay, good. Yeah, sorry to. Thank you for bearing with me.
Will you put the sign-in one more time?
Sure. Oh, thank you for reminding me, guys. Before you leave, I do wanna, redirect you to the sign in here. If you haven't gotten it, please do.
And then if you're interested in playing games Thursday, join ACM-W, and then Icpc is this weekend.
Oh, Alex, nice to meet you. What's your name?
Gabriel.
Gabriel. Nice to meet you.
Gabriel, yeah.
Yeah, I hope that was clear. Sorry, I kind of fumbled.
No, I was wondering if I could get like your Instagram or anything.
Oh, I don't have one. I'm sorry.
Oh well, I mean, you have a phone, right?
Yeah.
I'm gonna find your number.
Sure.